Good morning to everyone. Today's class bipolar junction transistor. In that, I am going to discuss about bipolar junction transistor current components and relationship between alpha and beta. That is amplification factors alpha and beta. Okay. Transistor current components. Generally, here I want to take the PNP transistor here. Okay. So the PNP, it is a active mode. The emitter current consists of two currents such as hole current IPE and electron current INE, right? Okay, let us come to the transistor current components here. So this is the PNP transistor structure. Okay, and here two P layers which are one is heavily doped, that is emitter region, and another one is another P layer is moderate doping level, it is called collector region, and lightly doped region in between the sandwich form, it is called as n type region, it is called base region. Okay, and here the PNP, it is a active mode, it is a active mode here. So if the device is in active mode device, then emitter base junction is going into forward bias condition and collector base junction is going into reverse bias condition. Okay, always if the device is in active mode, always these junctions, the junction emitter base is forward bias, the junction collector base is reverse bias. Okay, so here by giving this forward bias condition, here there is a movement of huge movement of charge carriers are moving, movement is occur in the emitter region, and those are cross over the junction JE and enter into the base region. Okay, and here the base region is lightly doped region, means it is having very less number of charge carriers. So by the less number of charge carriers, very few of from huge number of charge carriers are recombined with electrons in the base regions, that is 1 to 5% or 2 to 5% of charge carriers are recombination is occur in the base region, and the remaining 95 to 98% of charge carriers are enter into the collector region. Okay, and here one more point is by this forward bias condition emitter base junction, the junction depletion layer at J is very narrow here, and by the reverse bias condition for junction collector base junction is reverse bias, due to that JC is depletion region is very wider. As you know, we discussed in already we discussed in previous lectures like PN junction there. Okay, due to this forward biasing and reverse biasing, junction JE is very narrow and junction JC is very wider because of forward bias condition and reverse bias condition. Okay, let us come to this point here. By this forward bias condition, there is a movement of charge carriers occurred in the P region, it is emitter region. There is a movement of huge number of movement of charge carriers is that as whole movement. Due to that movement of charge carriers, we are expecting there is a current. That current is the same direction of movement of charge carriers. That current nothing but whole current in emitter region or emitter current due to the movement of hole. Okay, that is called as IPE. Similarly, here INE. INE means very. It is a negatively charged carriers are minority in the P region. Due to the forward bias condition, there is a movement of electron is also available. So that current is nothing but emitter current due to the minority charge carriers current, that is nothing but INE. So here the total emitter current is constitute nothing but IE equal to IPE plus INE, where IP nothing but majority charge carrier current in emitter, that is emitter current. And similarly, electron current in emitter region, that is minority charge carriers in the emitter region. Okay, that is electron. Electrons are the minority and holes are the majority. So the total number of current, the total current in the emitter region is this. It is equal to emitter current. Okay, and similarly here, very few of charge carriers are out of very few, or some of the charge carriers are recombination is occurred in the base region, nothing but recombination current. Okay, the recombination is occurred in the base region, that there is a current is generated due to the recombination, that nothing but IB. Okay, the remaining number of charge carriers are enter into the collector region by this reverse bias condition. There is a current is also available here, that current nothing but IPC, that is collector current due to holes. So the total current, the bulk current is available in the base region is difference in between emitter current and a collector current, that is nothing but base current. And here one more current is occurred in the collector region, that is nothing but ICO. Nothing but it is a reverse saturation current. Why? Because here we are applying reverse bias condition. Due to the reverse bias condition, the channel is wider. The channel is wider here, and here the P type. It is a collector region is moderate doping level. The channel is wider. Channel nothing but depletion region is wider here due to this reverse bias condition, and there is a movement is also available due to the minority charge carrier. That current is nothing but ICO. So this current is called as reverse saturation current. So these are the current components here. So by this total collector current equal to IC equal to IPC plus IPC plus ICO. This is the total current constitute in the collector region, right? So coming to these current components here, the emitter is heavily doped as compared to base. Thus, electrons current is negligible compared to holes. Okay. In the base region, in the collector region, sorry, in the emitter region, so this current will be negligible because of very less number of charge carriers. Those are having a current. Such carriers are nothing but minority charge carriers. That due to that minority charge carriers, it is negligible. Only the major charge carrier current will be considered here. Okay. So the electron current is negligible as compared to hole current. Next, all the holes are crossing the emitter junction and all are do not reaches to the collector junction. Okay, as I told you here, the huge movement of charge carriers are occur, huge number of charge carrier movement is occur here, but some of these huge recombination is occurred in this base region, remaining are enter into the collector region. Okay, so all the holes are crossing the emitter junction and all are do not reaches to the collector junction because some of them recombine with electrons in the n-type base. Okay, if IPC means collector current due to holes, 95 to 98% of charge carriers are enter into the collector region is a hole current at collector junction. So then the bulk recombination current in the base region is IB equal to emitter current minus collector current. Okay, and here the IE flows into the transistor. IE is flowing into the transistor here. Let us see here. The IE is here entering, and remaining two currents IB and IC are outing current. So means here the current, that is emitter current, flows into the transistor, and IB IC are flows out of the transistor. So we can write IE equal to IB plus IC by using Kirchhoff current law, KCL, by using the KCL law. Here sum of the entering current equal to sum of the leaving currents, IA equal to IB plus IC, right? And here almost all emitter current are flows to, or emitter charge carriers are flows to collector out of very few small flow out of from the base. Typically 95 to 98% of charge carriers will flow to the collector region. So therefore we can write IC equal to alpha DC into IE. So means here alpha DC nothing but 90 95 to 95 to 98% of charge carriers are enter into the collector region. So means almost the correct emitter current is equal to collector current generally. Okay. So where alpha DC is the emitter to collector current gain. Okay. From this equation 1 we can write alpha DC equal to IC by IE. So means, so here, so we can write the equation from equation 1, IC equal to approximately equal to IE, right? IC equal to approximately equal to IE because of alpha is equal to 1, nearly equal to 1, because it is a 95% to 98% of charge carriers are enter into the collector region. So then point nine to 0.98 is the alpha value. So this is nearly equal to 1 means IC collector current is equal to emitter current, approximately equal to emitter current. Okay. Next, the collector base junction is reverse bias. So a very small current flows. Okay. As I told you here, let us see here, the collector base junction is a reverse bias. So the junction is wider here. There is also movement of charge carriers due to the minority charge carriers. That current is nothing but call it as reverse saturation current. Okay. Let us see here. The collector base junction is reverse bias here. So a very small current flows through the junction. JC is called reverse current or leakage current, ICO. Therefore, the total current in the collector region IC equal to alpha DC IE plus ICO. ICO nothing but reverse saturation current or breakover current. Okay. Similarly here the leakage current is very small. Why? Because it is due to the minority charge carrier current. So it is negligible. Then IC equal to alpha DC into IE. We know that sum of the leaving current equal to sum of the entering current IE equal to IB plus IC. Okay. So here instead of IC, uh, see here in this from this equation here IC equal to alpha DC into IE. Okay. Instead of IE here we can place IE value, that is IB plus IC here. So from this equation IC equal to alpha DC into IE, but IE equal to IB plus IC, then IC equal to alpha DC into IB plus IC. So from this we get IC equal to beta into IB. Okay. So here beta is nothing but base to collector current gain. Base to collector gain. Beta DC equal to alpha DC by 1 minus alpha DC. Next, relation between the alpha and beta, or relation between the amplification factors of alpha and beta. So here we can discuss the, we know that beta equal to IC by IB. Okay, beta equal to, from this equation, beta equal to IC by IB here. We have sum of the entering current equal sum of the leaving current, IE equal to IB plus IC. So that is IB equal to IE minus IC. So instead of IB, you can replace with the IE minus IC. So beta equal to IC by IE minus IC. So dividing the numerator and denominator of RHS by IE, then beta equal to IC by IE all by IE minus IC by IE. From this we get beta equal to alpha by 1 minus alpha. So means here IC by IE nothing but alpha here. IE by I is cancelled, it is 1 here, and again minus IC by nothing but again it is a alpha. So means beta equal to alpha by 1 minus alpha. And we know that alpha DC equal to the ratio of collector current to the emitter current, and by the KCL, IE equal to IB plus IC, dividing the, and you can replace the value of emitter current with the IB plus IC, then again dividing the numerator and denominator by the IB value, IB, then we get alpha equal to beta by 1 plus beta. So this is the relationship between amplification factors of alpha and beta. Okay. So based on that concept, you have to calculate the problem also here. I was given here one problem here. So based on this current components and amplification factors such as alpha and beta. So based on all those things, you have to done this problem. Okay. So here the given data is here base current IB is given here, that is 20 microamperes. Okay, and when the emitter current is IE here, that is 6.4 milliamperes. And what are the values of alpha DC and beta DC here, and also calculate the collector current. Okay, but we know that IE equal to IC plus IB. Okay, but instead of B here, IB here, you can replace with the beta DC. Sorry, instead of IC, you can replace with the beta into IB. So replace this value with the IC. Then IE equal to IB plus beta IB. Okay. So the common factor is here IB here, that is 1 plus beta here. Okay. And then here 1 plus beta equal to 1 plus beta equal to IE by IB. Okay, right? You know the value here, beta value. Okay, you have to calculate beta value here. IE is here, so this is the IE value. IE is available here, and IB is available here. Then beta, you can calculate the beta. Okay, so this is the IE value, emitter current 6.4 milliamperes, the base current that is 20 microamperes, then beta, you have to calculate it. Similarly alpha is nothing but alpha DC equal to, okay, beta by 1 plus beta. Okay, you know the beta value, substitute in this equation, then you can get the alpha DC value. Okay, similarly IC, one more quantity here, you have to calculate it. IC equal to beta into IB. Okay, you know the beta value, you know the IB value, then you have to calculate the collector current. Okay.